Okay, today we are talking about percent yield. And first we need to understand what percent yield is. Percent yield is a number, a percentage that represents how much of a product that we got in a chemical reaction compared to how much we should have gotten. So if according to stoichiometry, if I do a calculation and I get a value, that's a theoretical yield. That's theoretically how much of this product I should get. In a lab during an experiment, I'm going to actually mix chemicals together or create some sort of chemical reaction that produces a product. And then I could measure the product and then compare that measurement to what it should have been. And that's basically what percent yield is. It is a measurement of how much I should have gotten in a reaction. So let's take a look at number 4 here. When hydrochloric acid is added to sodium hydrogen carbonate, the product is water, aqueous sodium chloride, and carbon dioxide gas. Let's go ahead and make our balanced chemical equation. So I'll start with hydrochloric acid, which is HCl, plus sodium hydrogen carbonate. So sodium has a positive 1 charge. Hydrogen carbonate, also known as bicarbonate, is HCO3. It has a negative 1 charge. So NaHCO3. Those are our reactants. And that is going to produce water, sodium chloride, NaCl plus 1 minus 1. So sodium has a positive 1 charge, chlorine has a negative 1 charge, so it's NaCl, and carbon dioxide gas. All right, so that's the reaction that we're looking at. So the question, how many grams of carbon dioxide should be produced when 10 grams of sodium hydrogen carbonate reacts with an excess of hydrogen? So that's saying I have 10 grams of this, and I have plenty of this, plenty of hydrochloric acid. But I want to know how much of this carbon dioxide should I make if I have 10 grams. Then you'll see it says, what is the percent yield if 4.68 grams of carbon dioxide are collected? So I did this experiment. I took 10 grams of sodium hydrogen carbonate, mixed it with a bunch of hydrochloric acid. It produced carbon dioxide gas. I measured that gas and got 4.68 grams. Now I want to see how close was this experimental value of 4.68 grams to what it should have been. And to answer that question, I need to do some stoichiometry. I need to calculate the mass of carbon dioxide produced by 10 grams of sodium hydrogen carbonate. So I'm going to go to my dimensional analysis. So dimensional analysis setup. This question is asking me for grams of CO2. And I don't necessarily need this. The question here gives me, how many grams of carbon dioxide should be produced with 10 grams of sodium hydrogen carbonate. I don't necessarily need that statement. If this is asking me for the percent yield of 4.68 grams of carbon dioxide, I should know that I need to get a theoretical yield for grams of carbon dioxide. All right, so now that I know where I'm going, I can identify my starting point, and that's 10 grams of sodium bicarbonate or sodium hydrogen carbonate. All right, now I need to get into my conversion factors. So I'm going to make a mole ratio between CO2 and NaHCO3. I just thought I have not actually balanced this equation or checked to see if it is balanced. So let's go ahead and do that. I'm just going to go ahead and evaluate each side. So I've got 2 hydrogens here in the reactants, 2 hydrogens in the product, 1 sodium, 1 chlorine, 1 chlorine, 3 oxygens, and 1, 2, 3 oxygen. So it's already balanced. So my coefficients are all 1 mole of CO2, 1 mole of NaHCO3. Grams here tells me I need a molar mass conversion factor for sodium hydrogen carbonate. So 1 mole of NaHCO3 to grams of NaHCO3. Running out of room there. So I have to add up the mass of every atom. So mass of sodium is 23 plus hydrogen, which has a mass of 1, plus carbon, which has a mass of 12, plus oxygen's mass is 16 times 3, and that gives me 84 grams of sodium hydrogen carbonate. And then this grams here tells me I need a molar mass conversion factor for carbon dioxide. So I'm going to make another molar mass conversion factor, 1 mole of CO2. Remember, your molar mass conversion factors will always be 1 mole. It doesn't matter what this coefficient is over here. When I'm doing molar mass, I'm just figuring out the mass of 1 mole of a substance, because that's what molar mass is defined as, the mass of 1 mole of a substance. So grams of CO2. Carbon has a mass of 12. Oxygen has a mass of 16. So 16 times 2, 32 plus 12 gives me 44 grams of carbon dioxide. Now I can go ahead and take my conversion factors and plug them in. So I have grams of NaOH up here. I want to get that down on the bottom. So I'm going to plug in this conversion factor first. 84 grams of NaHCO3 to 1 mole of NaHCO3. Now I can plug in, so done with that. Now I can plug in my mole ratio. 1 mole of NaHCO3 to 1 mole of CO2. And now I'm done with that. I can plug in my final conversion factor. I'm going to flip this over because I want moles of CO2 on the bottom, so they cancel out. 1 mole CO2, 44 grams of CO2. Check there, make sure everything cancels. Grams of NaOH cancel. Moles of, NaHCO3. Moles of NaHCO3 cancel. Moles of carbon dioxide cancel. I'm left in grams of CO2, and that's what I want to be left in. So that's fantastic. So now all I have to do is my math. 10 times 44 divided by 84, and that gives me 5.24 grams of carbon dioxide gas. So now I've answered this question here. How many grams of carbon dioxide should be produced when 10 grams of sodium hydrogen carbonate reacts with an excess of hydrochloric acid? That's the answer to that question. But then the second question is, what is the percent yield of 4.68 grams of carbon dioxide? Again, the purpose of percent yield, this value, my theoretical value, is theoretically how much carbon dioxide gas should I have produced. This value represents what was obtained in an experiment. So percent yield is going to show me the relationship between those two things. So I'm going to use my percent yield equation, which is actual yield divided by theoretical yield times 100. So we've got 4.68 divided by 5.24 times 100, and that gives me 89.3%. So again, that was 4.68 divided by 5.24 times 100 equals 89.3% yield, which basically means that in my experiment, I obtained about 89% of what I should have obtained. And that's what percent yield is all about.